I think I'm going to get started. My name is Lee Sobotka, and I'm giving the third lecture in this Compton Centennial celebration. And the first lecture had to do mostly with the work that Compton did that led to his Nobel Prize, a little bit more. The second one had to do, there's a few people outside. Maybe I should welcome them in. Come on in. The second one had to do with Compton's role in the Manhattan Project. A little more, but that was the main thrust. And initially, I was given the task of talking about Compton's influence on chemistry at this university, but I'm going to broaden that a little bit. So here's an image. You're sailing. You've got pretty good wind, and the boat is making good head speed and water speed, and it's really tempting to look back because there's just a beautiful wake, and it's really pretty. You always look back, but you got to focus on what's in front. But the wake is just beautiful. It's breaking on the side of the boat behind, and Compton left a fantastic wake in terms of the people that were around him, followed him. And,
Lee, we can't see you.
well, that's not someone just said actually complained that they couldn't see me.
There you are. There.
We need you, to speak into the microphone. Thank
Yeah,
you.
you're sometimes not speaking into the microphone.
Okay, is this better?
Yes.
Yeah.
Hi, Dave.
I'm not sure your slides are showing either.
Okay.
You change slides.
All right. Can you hear me now?
Yes.
Okay, I will try to confine myself to this side of the table. I tend to wander, glue my feet to the floor. Okay, so you have this wake, and I'm going to tell you about some of the individuals in this wake. And it's not just chemistry. But there are some fantastic stories that I'll relate along the way. And about other stories, but maybe you'll be interested in asking. It might be better if you turned off, the remote people, if you turned off your microphone. There's some feedback here, and that may be the problem for other people trying to listen. Okay, so I'm going to talk about some of the greatest moves at WashU that occurred under Compton. I'm going to talk about what I consider WashU's finest hour, which was sort of related to Compton, but not, well, part of it is under Compton, part of it was under his successor. And then I'm going to actually talk about a mistake, arguably the biggest mistake in terms of the scientific disciplines here at WashU, which occurred post-Compton. Okay, maybe the order won't be quite this way. I want to go forward. Oh, okay, enable, maybe I have to do this and come back here. Okay, so I had a little help with this talk. John Clark, who's on Zoom, Al Holzer, who's sitting right here, and these two gentlemen knew Compton, and most of the characters, maybe all of the characters that I'm going to talk about here. So I only knew some of them. Those two guys knew basically everyone, and some of the information on transmitting came through these two people. And Theo Vandervelde is at the med school. He had some slides that he sent to me a while ago for a different reason. And also I had some slides from Michael Welch is deceased, but he, sorry, you see I'm roaming. These are people from the med school, and you'll see there's a strong med school story here, okay? And so those help. Also, there's two books, one by Martin Kamen, you'll see where that comes into play, and really the official history of Washington University, written by Ralph Morrow, and there's a number of things from that book. So that's, and of course, some of the stories I'm going to tell you came from the principals. Okay, so I have to put the some of the things I'm going to say in historical context. The WashU cyclotron was running in early 1940. It was, the construction started actually in 39. It was built very quickly. It was running in early 1940. You could argue, WashU people might argue, it was the first cyclotron outside of Berkeley, California. People at Columbia would argue that they were the first outside, but okay, it was within the first couple. And it had, it wasn't high, very high energy. Berkeley had tried to make their cyclotrons go higher and higher in energy, but it was incredibly high current. It could produce a lot of radioactivity. So it had that feature. And it was running, as I said, before the US got involved in World War II. Compton accepted the chancellorship just after World War II ended in April 1945, just to, before the end, before the end of World War II. Hiroshima and Nagasaki were bombed on August 6th and 9th, respectively, in 1945. And for those who are a little less engaged in history, that they often forget that Russia played an important part in the surrender of Japan, because they occupied the northern territories, 4 islands, actually post-bombing, and continued this invasion even after, a few days after Japan surrendered. So if you're going to talk about the surrendering of Japan, you have to consider both what happened in the bombing and what they feared and saw was happening from Russia. Okay, so you can't separate that out. All right, now I'll refer to the Magnificent Six through this talk. This are people who came to WashU to chemistry, and this is in quotes because it comes from, this term was coined by Ralph Morrow in this book I mentioned. And much of the talk will have to do with those 6, and they came shortly after the war ended in the spring of 1946. They were all at part of the Manhattan Project at Los Alamos. That project concluded, or they're part of it, and they came here, and I'll tell you how that happened. But that group transformed chemistry and a good deal more on the campus. All right, now and another hire came a little bit later, and this is perhaps the most interesting story. And this person came to radiology, but not from the Manhattan projects. He was working on the docks in Oakland. Okay, and you'll see why he was working on the docks in the course of this talk. All right, but before I get to that, this wake. So first part of the wake was his students. Grand student, great grand student. Okay, so this is Compton. He won a Nobel Prize in 1927. And Eric told you why. He had a student named, everyone called him Louis Alvarez. He got a Nobel Prize in 1968. I could tell you 10 things that he could have won the Nobel Prize for. This was I knew him a little bit. He was just an incredibly versatile scientist. Studied helium-3, studied beta decay. He devised a procedure to look inside of pyramids to look for voids using cosmic ray muons. He advanced the theory that 60 million years ago, an asteroid hit the Earth. Dinosaurs died at that time, and the evidence that remained was a layer of iridium that ringed the Earth. Okay, that all came from this guy, student of Compton's. He had a student named Richard Muller, knew him a little better. He was on my thesis committee. Now, he didn't win a Nobel Prize. Maybe he thinks he should have, but he's another incredibly versatile scientist. He wrote a book called Physics Every President Should Know. It's a good read. He's a fantastic, innovative instructor. He does astrophysics. He also went back and looked at the original invention of the cyclotron, which accelerated positive ions, and said maybe there's a better, maybe for certain purposes, it's much better to accelerate negative. And now, in fact, every medical cyclotron using this devoted to creating isotopes accelerates the hydrogen anion. In other words, it's a proton with 2 electrons, okay? He actually did it for another reason. He wasn't thinking about medicine. He was thinking about carbon-14 dating, and he lost out to another technology in that front. But the cyclotrons that we have, actually 4 of these down at the med school, they're all negative ion cyclotrons. Okay, so that came from his group. And then he had a student named Saul Perlmutter, and he got a Nobel Prize. Okay, Nobel Prize, close, Nobel Prize. And what did he get a Nobel Prize for? He studied a type of stellar explosion called supernova type 1A. They're called standard candles. And it's at the crux of understanding, or the hypothesis, there's something called dark energy. Okay, so that's what he got to know. With 2 other people, he got the Nobel Prize. This is incredible string. How does that happen? Is that an accident? No, it's not an accident. You'll see why. All right. I was tasked with talking about people in chemistry, but I can't just jump to them. So I'm going to talk about people that came in physics first, okay? Just after the war, these people were hired. One was Eugene Feinberg. Eugene Feinberg was a master of many body quantum mechanics, studied condensed helium-3 and helium-4, made tremendous advances in the theory and understanding those fluids. He was here from the end of the war till his death. Oh, about the same time, a guy named George Pake was attracted to WashU. He really started, or was one of 2 people, I would say, that started the magnetic resonance powerhouse that WashU was for many decades. Following him came a guy named Richard Norberg, who invented something called Fourier transform, NMR, and that's, you can't find a machine that doesn't use that technology. They just, okay. So Pake came here he was one of the wake under Compton, so to speak. There was a guy named Henry Primakoff. Heard about weak interaction, beta decay. Sometimes you may hear it's in a double beta decay. This is the man, okay? Now, he didn't stay here his whole career. He left in the 50s, and his departure was the biggest mistake, okay? Now, in describing that mistake later, I actually won't talk about him at all. I'll talk about his wife and nepotism rules that existed at the time that prevented WashU from giving her a position, so they both left. 2 giants that WashU let slip through their fingers post-Compton. Okay, if he was still chancellor, would it have happened? I don't know. Then there's this guy, Robert Sard, who one of Compton's interests that you'll find next week was in astrophysics and interested in cosmic rays. And we still have an interest in this department, a strong effort in cosmic ray science. And this was the guy that got that started here. And he also came here under Compton. Okay, so all those people came in physics and started big programs that you could argue are still going on today. But what about chemistry? These are the Magnificent Six that came from the Manhattan Project at Los Alamos National Lab to WashU just after the war. Remember, this was, what is it, April 1946. These people showed up. The ringleader, these look like mug shots. You know, so I could say, you know, this guy was actually the ringleader, but maybe it might think it was Al Capone from looking at these mug shots. But no, this guy was the leader, and I'll tell you a little bit about him. But at Los Alamos, he was the head of chemistry and metallurgy. There was important metallurgy part of Manhattan Project. And this comes important later, he was the head of scientific security. Okay, and he was still in his 20s, late 20s, when he was given those tasks. This guy and this guy were the two principals in the discovery of plutonium. People often associate it to Seaborg. Don't have time for that story, but these are the guys. These are the guys that did the work and so forth. Tell you a little bit about Lindsay Helmholtz, a little bit about Dave Lipkin, a little bit about Sam Weissman, and a little bit more about the role that this guy played, Hebert Potratz. And I actually alluded to it in some comments that we had last week, and you'll see. So all of these people were magnificent scientists, and in fact, shook the world in many senses. Now, I'm still continuing on the wake, okay? We talked about students, we talked about the hiring in physics, we talked about the hiring in chemistry, and now the hire that took the most courage. This guy, Martin Kamen. If two things didn't happen, he probably would have won a Nobel Prize because he was the discoverer of carbon-14, arguably the most important radioactive isotope there is. Allows us to do dating. It allowed photosynthesis to be unraveled. But he didn't get the Nobel Prize for two reasons. First of all, he had a collaborator who died in the other World War II project. What do I mean the other one? Well, you all know about the Manhattan Project. But most people don't know that the US also had a chemical warfare project. Offensive and defensive. Of course, we were worried about what the Germans did in World War I with chlorine gas. And we didn't want to get caught off guard. So there's a lot of people involved in that, a lot of chemists. His partner in the discovery of carbon-14 was in that program and died in the course of that study. So you can't give the Nobel Prize to someone who's dead. And you couldn't give it to this guy because he was blackballed. He couldn't get a job for reasons I will describe later. And therefore he ended up working on the docks. Until Compton showed true courage and brought him here to WashU. And he couldn't get a job at Berkeley or many universities in the country, but Compton brought him here, even though he was blackballed. That's courage. That's Compton. Okay, now I'll save this story, the details of this for the end, but I'm getting you a big tease right now. Okay. So now I'm going to get a little bit more history. Compton, we have to go back to about 1938. That's when Compton had a role. He had been here as a professor. He was at Chicago at the time, I think, but he was writing this somewhat later, and he instigated. Well, this was not written in 1938. It was written later, but the story about the cyclotron starts in 1938. And he describes in this document the cyclotron coming to WashU. The chairman of the physics department at the time was Arthur Hughes. I don't really know his expertise. He was involved in the Manhattan Project, and he left a couple of messes around the physics department. One of them I had to clean up. But Arthur, this was probably written in about the 6 or so. Compton was chancellor. And the important thing about this, this is about the cyclotron, has to do with the fact that if you look at this, Dean of the School of Medicine, the director of the Mallinckrodt Institute of Radiology, med school, was heavily involved from day one. And there's a guy here, Bob Thornton, and it says physicist in charge of the cyclotron. He's on leave. Now he's going to come back in this story later. On leave from where? Berkeley. He was an essential member of Ernest Lawrence's team, the team that developed the cyclotron. But he came to WashU on leave to help build and run the cyclotron here. And then he went back to Berkeley. When he went back to Berkeley, something interesting happened. Okay, so this is a picture of the guy at the med school, the director of the Mallinckrodt Institute of Radiology around 1938, when he's saying, yeah, let's build this cyclotron. Here it is, a picture of it. I'll give you a better one later. As I told you, it was running in 1940. It was a machine that from day one was dedicated to producing isotopes for medicine. It was on this campus, not the med school campus, because a power plant was here and it needed a lot of power. And as you'll see later, med school really wasn't prepared at that time to run a cyclotron. By the way, as I said, they have 4 cyclotrons and 2 synchrocyclotrons now running at the med school. Okay, but at the time, this was not in the med school bailiwick to try to run this machine. So they put it over here and you'll see. Okay, it was funded by the Rockefeller Foundation, was installed to produce short half-life isotopes for medical use. And it earned a colorful footnote in US history when the Manhattan Project used it to create some plutonium. We'll get back to that in a little bit. Now, I think this guy right here is this guy, Robert Thornton, on leave from Berkeley. Okay, so what did it do? It produced radioactive phosphorus and iron, the first for leukemia treatments, the second for doing some blood chemistry research. It produced sulfur and arsenic that went to the National Cancer Institute. Okay, now here is a letter. I want to go read it through, but it's a letter from Compton saying, okay, the med school has said we can't handle running this. We want to, even though we got the money for it, for producing radioisotopes, we want to transfer the responsibility to the physics department, where it's better expertise, and the physics department promises to deliver these radioisotopes to the med school and around the world, okay? Which is what the Rockefeller Institute wanted. They wanted these isotopes made and distributed. So this is a letter from Compton saying, yeah, it's being transferred to the physics department, Hilltop campus. This one, we'll run it, but we'll satisfy those needs. This is a better picture of the machine. It's what's called a classical isochronous cyclotron. And our ions go around and around in circles in here. And these things that are standing off now that you usually be touching over here are what controls the RF. And it looked about like this with the RF stems attached when I first saw it. And that was in mid 1980s. And, but it was being decommissioned then, and I was sort of in charge of taking it apart. And a request came from the Smithsonian, said, we really want this machine because of the role it played. Problem was, the building was built around it. So we had to carve it up, weld, torch it, and cut it into pieces. And then the Smithsonian really didn't want to put it back together again. So could have had a machine in the Smithsonian, but that was the way it went. Now this place is a mass spectrometry lab in the chemistry department. Okay, this is the original control room of that. This is high tech, 1940. It was updated when I saw it. It wasn't quite like this, but it was looking pretty shabby when I first saw it in the 80s. Anyways, it was all ripped apart. This, if it hadn't been updated, that would have gone to the Smithsonian. But it was updated, so they didn't really want to use it. Okay, now this is a beam coming out of it. Now I know there's a radiologist here, maybe more. This is the beam coming out in air, and maybe you can see something called the Bragg peak. So the ionization is not so large, and it gets very large at the end. Now there's 2 machines that are shooting these, they may even be running as we speak, that go around a patient shooting at all different angles. And the intense part is ending up on the cancer where they want to destroy the tissue. But there's less damage on the incoming side and no damage beyond. And if they can put that intense peak right on the cancer, then they do a lot of killing, cancer killing, and not a lot of healthy tissue damage. So there's 2 machines like that now at the med school. And they're very likely operating right now as we speak. And that's at the S. Lee King Proton Therapy Center. But here you can see the Bragg peak. You can see exactly why physicians were interested. Okay, so why was the Smithsonian interested? 2 people, I told you those 2, Art Wahl and Joe Kennedy. Seaborg, Segre, Macmillan, arguably, were the first to produce plutonium in incredibly small amounts, really less than a milligram. Couldn't really see it. But that was a discovery, and I'll show you that paper in a little bit. That was in one of the original Berkeley Ernest Lawrence cyclotrons. The cyclotron here, as I said, was higher current, more powerful. We could produce more. And up to around 1944, it produced maybe a gram, roughly speaking, 1,000 times more than was produced here. But 3 orders of magnitude, so maybe this was an increase of 3 orders of magnitude. But as soon as reactors came online, first at Oak Ridge, and then at Hanford in Washington, there was no point in running these cyclotrons to produce plutonium, and the reactors produced what was required for the Nagasaki weapon. But WashU did produce during the war, early part of the war, most of the plutonium used for studying the chemistry, both in the Chicago Met Lab and at Los Alamos. Okay, but as soon as reactors came online, that was pointless. Okay, so again, these are the Magnificent Six, and I want to tell you a little bit about these fellows. So now I want to quote Al Holzer, who's sitting in the audience, who wrote this not too long ago for a separate occasion, and I think it's worth reading. The Six brought with them not only outstanding scientific gifts, but a spirit and an attitude featuring irreverence towards authority. Find that pleasing. Fierce devotion to academic freedom, uncompromising intellectual honesty, and a love for science that soon pervaded the atmosphere. Boy, those are things just to die for, right? I mean, that's what an academic wants to have. They had it with gold stars. This is about a picture taken about when I came on the scene. Didn't know Lindsay Helmholtz very well, just met him a couple times. This is Art Wahl, one of the discoverer of plutonium. Knew him very well. Sam Weissman, I'll tell you a little bit about him. He initially worked with Lawrence on isotope separation at the thing that became the prototype for a calutron. And Dave Lipkin over here, I'll tell you a little bit about what he did in a moment. But this was the remainder of the Magnificent Six when I arrived. So Joe Kennedy was the discoverer of plutonium and one of the discoverers, and the head of chemistry, metallurgy, and security at Los Alamos. Lindsay Helmholtz was a superb, what you call inorganic chemist, and there's something called molecular orbital theory, which people learn for the upper parts of the periodic table, but he made really important contributions beyond that. Dave Lipkin, during most of his career, studied aromatic a certain type of organic entity, but in the Los Alamos project, he solved a big problem, and that is plutonium oxidized, and you had to have something that around it that prevented that, and he actually put the nickel coating on the plutonium pit. And that guy, remember Louis Alvarez, he was the student of Compton. He was at Timian, he was the receiver of the weapon before it was put on the plane. In fact, he followed in a separate plane. And when he got this pit and he held it in his hands, literally, he reported back, it has a skin you love to touch. It had this nickel coating. It was safe to move around and so forth. Okay, now another guy here is Hebert Potratz. I'm going to tell you about his story in a minute, and that involves it gets to the Alsos mission, which some of you heard about last time, but I'll tell you a little bit more about it. Art Wahl was the guy who did the chemistry for the discovery of plutonium, and he was the generator of what you really, the systematics of what is produced in fission. So you have a big nucleus, it splits into two. What are the distributions of the elements that are produced? Art Wahl, everyone in my field just calls it the Wahl systematics. How much of this element, how much of that element? It's totally Art Wahl's work. And then Sam Weissman. What happened here? It's not going forward. Okay, so I guess maybe I skipped it. Okay, maybe it's in there in a little bit. Okay, so I want to bring you back to something that Mike Ogilvy had in his talk, which was this sketch of the first man-made nuclear reactor in this squash court in Stagg Field, or underneath Stagg Field. And he told you that they didn't run this for very long. They took it apart and then they moved it and built CP2 in what was then a forest in Argonne, south of Chicago. I should point out, people say it's the first reactor. I think it's more appropriate to say the first human constructed reactor, because on the planet Earth, nature had built its own nuclear reactor that was studied by people here, and that's an interesting story. But it's the first human constructed reactor on the planet Earth. Now there's a feature over here that's kind of interesting. If you look at this, there's a weight hanging here, and there's a line going up and a line going up. What's that? That's the safety control rod, and then there says Axeman. So someone could stand up on a ladder here, and if the reactor got out of hand, you could cut that weight off. And if you cut that weight off, the control rods immediately fell in from the top, shutting off the reactor. If any of you saw this movie about what happened in Chernobyl, there was a button, and if someone pushed a button and the reactor didn't go off very fast, that's because the scram procedure was designed poorly in a number of ways, but one of them was it was very slow. This was designed, you cut it, and your control rods went in immediately. Okay, so, but this thing worked. Why did it work? It worked because Leo Szilard, one of the brilliant Hungarians that came over to flee the Nazis, was in Fermi's group, and he knew that if you use normal graphite in this reactor, the graphite is to slow down the neutrons, that if you didn't remove boron, the boron would eat the neutrons, and instead of the fission producing so many neutrons, and then one of them would come around and initiate another fission, and then there'd be a granddaughter generation, you'd have this growth that Michael talked about last week. If you had too much boron in there, the neutrons would come out and be captured by the boron, process over. Szilard knew it, and he needed a chemist to get the boron out. Hebert Potratz, that's the guy. And he had to do it on an industrial scale. So he designed the procedure, he worked with a chemical company, and he created tons of graphite free of boron. And similarly, not only for this one, but for all reactors, graphite reactors. Okay, so that was what Hebert Potratz did.
May I also point out that Germans didn't know this. and they-
that's this slide right here. So
Sorry.
thank you very much. So the Alsos mission was a mission to find out what the Germans knew about how to build a reactor and a bomb. And there's a book by Jeremy Bernstein about this. And there's really two parts. One of them was that after the war in Europe ended, but before the bombing, the German scientists were collected at a elegant house, farm hall in England, bugged up the wazoo with translators in the basement, some German military high officials there also. And they were given a radio, bombs were dropped, and they started arguing. What happened? Why didn't we understand this? And so forth. Okay. There's another part of it, which was that Goldschmidt led a crew to go into Germany to find their reactor. Okay. And they found it. Here it is. They took it apart. This guy was part of the Manhattan Project himself. He was a scientist. Goldschmidt, I don't know where he is. He's not in this picture. What was their principal goal in finding this reactor? To get those bricks, send them back to the US and find out if they had boron in them. They did. Wouldn't work. That's why, and actually part of the discussion in Farm Hall with why didn't we understand this was because they had contaminants in their samples. Those contaminants, the guy named Boda didn't realize how important those contaminants were. And so they had poor information on the relevant cross sections. They thought the cross section for absorbing a neutron for a certain element was a number. It wasn't because they didn't do it on pure enough samples. Okay, so that's described here. And again, what's the bifurcation between US and Germany? We knew to get the boron out. Who got the boron out? A guy that came here after the war. Okay. Now, this is the discovery paper of plutonium. It's from these people at Berkeley and Seaborg, who I knew very well and was peculiar in a number of ways. And Macmillan, another senior guy who actually wasn't there at the time of this discovery. And then Joe Kennedy and Art Wahl. It's sort of in reverse order of who did the work. Not what we would do today, okay? But it's actually characteristic of young Seaborg. Anyways, this is the first page of this paper. Oh, wait a minute, maybe I said that wrong. This is the last page of this paper. Oh, wait a minute, it's the only page, okay? And it's not even a full page. And it changed world history. And you can see something else that's very unusual. By the way, it says everything you need to know. There's no, they didn't fill us with extraneous stuff. Just cut to the chase. It's a beautiful paper. Now there's something else that's very interesting. You see it was published April 1946. Remember the war was over in August 45. So it's about not quite a half a year after the war ended. When was it submitted? January 1941. In fact, this paper, some people, young people say, we gotta get published, we gotta publish it fast, we gotta publish it. It's so important. And no, here's a case. It's so important, it wasn't published. Okay, in fact, there's a little footnote here. And what does that footnote said? That everyone agreed to hold this off till the end of the war. Published it, okay? All right, so I think that's two members of the Magnificent Six, Art Wahl, Joe Kennedy. Okay, they came here after the war, along with the guy that got the boron out. All because of Compton. Now here's a picture of Art Wahl. young Art Wahl. By the way, when he discovered plutonium, he was 24. Okay, 24 years old. And he was the best actinide chemist in the world. I have other stories about that. Oh, here's the thing about Sam Weissman. I really don't have time to talk about the accomplishments of this guy. It could fill 2 hours. So these are all of his scientific accomplishments. He's in the National Academy. He was brilliant and unassuming, like all of these guys. He read quantum mechanics for bedtime reading. He approached science with innovative and unique perspectives, generating much of these accomplishments. And he actually walked the corridors of the chemistry buildings hunting for conversation victims. So I was intrigued with this guy when I came, and I have to admit that there's a couple of times that I set him up. I knew he would be walking around looking for conversation victims and people to engage. So I set myself up for him to find me. I knew he was walking the corridors. I walked that corridor, maybe. And then he'd nab me, and then it would be a fantastic conversation. He was a storyteller of really incredible inventions. So this, again, one of the people that Compton brought here. And here's a picture of him. And look at the smile, look at the face. And I look at that and I say, he's a little older than I am now in this picture, but not much. And I mean, that hair, look at that hair. That hair is to die for, right? Fantastic. That hair and that smile. I mean, my God, can you get any better? Okay, now, so Compton had this history of his students and the people he brought here, and say, well, are there other people like that in the world? And yes, in chemistry, there's one named G.N. Lewis, and he had a tremendous string. He was at Berkeley, and he really made University of California, Berkeley chemistry a tremendous center. And he had this same way. And actually, many of the people I described, I said they came from Los Alamos. They came from Berkeley, Los Alamos, WashU. So they were in GN's wake, okay? And here's a picture of Sam and young Townsend in physics, working on probably one of the early electron spin resonance spectrometers. Another picture working with his good friend Dave Lipkin and some younger colleagues. There was a tremendous line of researchers here in chemistry and magnetic resonance, and it all came from this guy Sam Weissman, who had colleagues in physics, and it worked great. But it was more than that, this trend. How many remember in this crowd, probably this crowd, should Barry Commoner? Okay, so Barry, was it 1980? I think it was 1980 he ran for president. Is that right? 1980? Something like that, right? Well, people around of a certain age remember him for that. But in fact, he was a biology professor here. And his advances came from, some of them came from working with Sam Weissman. So there was a flow, if you will, from this Compton hired people into biology also. And another person in biology, how many, maybe many met Danny Cole, who died a few years ago? Anyways, another person in biology who studied photosynthesis, and he was influenced and helped by Sam a lot. Okay, now I want to get into the bigger story. All right, loyalty oath. I'm going to put some stuff up here. We don't have time to read it, so I'm going to cut to the chase. Sorry. After World War II, sort of leading into the 50s, there was this Red Scare, and McCarthyism, beginning of McCarthyism and so forth. And many universities had loyalty oaths. And one of the places we now consider a bastion of liberalism, University of California, Berkeley, where many of these people came from, had a loyalty oath. And Berkeley, so this was in the 1950s, they forced people to sign an oath. Board of Regents fired some, then they were forced to rehire them. Berkeley lost a couple of super duper duper stars because of this. One was Panofsky went to Stanford, one of the people who made Stanford. And a guy named Wick, who was an Italian nuclear theorist that showed up at Berkeley, found out about the loyalty oaths and said, screw this place, I'm leaving. And he actually changed the direction of science at Berkeley because he wasn't there and where he went to. Okay, so this is a little piece of sordid history from Berkeley, a stain on Berkeley. And in fact, there was the free speech movement, you can argue, was a ricochet from that, a rebound from that. So they went one way, they went the other way. So there's a historical trend there. And the people that came here were not in that Berkeley at that time, okay? They didn't have to deal with that there, and they didn't have to deal with it here. By the way, this is a picture of what was going on in St. Louis about that time. Pauling is a famous chemist who had his, story of Watson and Crick and Rosalind Franklin and this, who knows that story? Well, we probably wouldn't know too much about Watson and Crick if Pauling's passport wasn't revoked. He couldn't go to have a meeting with Wilkins and Franklin because he was his passport revoked because of his left leanings and his anti-hydrogen nuclear weapons stance. So he had his passport removed, and that's a long history. But the point is, that's what this statement is. Pauling, pinko, parasites, whatever. So this was going on in St. Louis. But what about the university? After Compton, Shepley was named to the chancellorship, and these two guys, Compton and Shepley, set a high water mark for chancellorship, and for academic freedom, this guy Shepley won the Meiklejohn Award for academic freedom, and that's going to bring us to this guy, back to this guy, Martin Kamen. Remember, I told you he was the discoverer of carbon-14, along with someone who died in the chemical warfare project. And I have to now tell you why he was blackballed and therefore could not get an academic job until Compton intervened. All right, again, I don't want to read all this, but the basic story is this. He was working on radioisotopes with on Lawrence's early cyclotrons, and Ernest Lawrence's brother was John Lawrence. Like you could argue he's the father of modern radiology and use of radioactivity in medicine. And he was working with him, and there was someone who had cancer in the Russian consulate, and they just asked Kamen, what was going on? Is there something he could intervene and help to treat this ailing Russian? Remember, they were allies at this time. And there were some initial discussions, and then the Russian consulate wanted to thank him for starting some discussions, and they took him to dinner at a famous fish restaurant down by the bay, Bernstein's Fish Grotto. And they were tailed by a gumshoe to this restaurant. Sitting in the next booth was was it OSS? I'm not sure, but some gumshoe who didn't hear the conversation, but heard the words radioisotope, and it was between a scientist, US scientist working with Lawrence and someone from the Russian embassy. From that point on, his life was hell. Okay, couldn't get a job. There's another incident too, having to do with this, that caused him problems. But it was then I received a surprise visit from Robert Thornton. Remember that name? He was the guy on leave in 1938, 39, 40 who came to WashU to help it run. Now this is a couple years later. The Washington University cyclotron was running. This guy was back in Berkeley. Okay, surprise visit from him. As I said, EOL is how everyone called Ernst Lawrence, the inventor of cyclotron. His name never was, anyway, it was just EOL. Came with an attractive offer of employment, basically, read all this, at Washington University, mediated by the Chancellor, Arthur Compton. This guy was blackballed, couldn't get a job. Compton comes with an offer, okay? And so he had a choice. He could continue unpacking ships on the dock or come to St. Louis and do science, okay? So he came to St. Louis, and it was a great time to be here. There was a lot of, but to radiology, not to this campus, to the med school. And what was he coming for? He was coming for to teach them tracer techniques. Remember, this is the discoverer of carbon-14, used other isotopes, which we were now making at this cyclotron. And he was, it was really a master of those of radiochemistry techniques for that. I won't go through all of this, but it turns out that things weren't so rosy here, not at the university, but he was accused of being a security liability by a Chicago newspaper. Was it the, hold on. Which paper was it? Okay, I don't know which paper. Anyways, Tribune? Anyways, he filed a libel suit against the newspaper. They called him a security risk, and he sued them. And in his defense came Compton and Kennedy. And I just want to tell you a quick story about some of that defense. He won his libel suit. So how did he win? Well, this one scene. So imagine, see, I have to go back. Maybe I have to go back to show you. Oh, it's gonna, so that's Kamen, the guy we're talking about. And I'm going to go back. Oh, to this slide. And then this is the character. Remember, he was head of chemistry, metallurgy, and scientific security at Los Alamos. And he always looked young. So he came to what this was, he probably didn't look much older than this. And there was this trial. And so in Kamen's defense, he calls Joe Kennedy. Looks like this. And you know, is Kamen a security risk? It says no. Okay, fine. Then the other side comes up and they see this kid who looks like a punk kid. And the lawyer says, have you seen this book? This brings up the Los Alamos security manual. And because the issue was he a security risk? So, you know, he looks at it. But yeah, I've seen this book before. And he doesn't say anything. He just hands it back. And then the lawyer for the paper hands him another book, and it's the security manual for the radiation lab at MIT, develop radar. So he looks at it, says, yeah, I know about this book, but I actually never held one in my hands before. Okay. And then the lawyer says, well, you know, remember for the paper, saying, well, you know, what kind of person do you have here? He's a security expert. He doesn't really profess much knowledge about security. And okay, this guy here pauses and said, well, wait a minute. The first book you held up, if you open it up and even looked at it, you'll find out I wrote it. And the second book from MIT, if you look into it, you'll see there's an acknowledgement that it's mostly a copy of my book. Okay, at which point the lawyer apparently, the judge sitting in decision on this turns around and starts laughing. Okay, so this guy came to the defense of Kamen, as did Compton, and that's the characters we had at that time here. Okay, now I have to go way forward because there's just one little story left. So that's Kamen. By the way, I put this in the record if you want. You can get a copy of this talk. You'll see this, you look at the books and get everything, but I just put it all in here. Okay, so in summary of that story, falsely accused of being a security risk, blackballed, Compton hired, Compton, Shepley, and Kennedy defended. Okay, I'd say this was WashU's finest stuff. Now, there's many stories about, there are other stories about Kamen. He was world-class violist as well. This was one of his good friends. And there's a story there too. Okay, do I have time for that story? Maybe I'll tell you that story. Okay, quick story on that. So at Berkeley as a graduate student, Kamen had a collection of friends who were pretty damn good. And they played regularly together. And then at one point, a woman comes in and because she hears about this group and she says, would you mind if my son plays with you? Now, these guys are pretty darn good. And they, they're basically professional quality, but they have careers in science. Now, how old is your kid? 13? What's the point of this? It's, they didn't want it. They weren't pompous. Okay, let the kid come. Wow, the kid was good. They were lifelong friends. Okay, so that's the story of Martin Kamen. And now the final story. Now I went to I just told you a fantastic story. WashU's high point. I'm going to go to a low point. This is a post-Compton. I told you about this guy, Henry Primakov, who was weak interactions, beta decay, double beta decay. There's a Primakov effect named after him. He's a monster in theoretical physics. His wife was equally accomplished. And this is a picture of Mildred Cohn. She used, remember I told you there was a lot of magnetic resonance people here after the war. Well, she was using magnetic resonance to study enzyme reactions and a particular compound that's important in biochemistry for energy transport. She ultimately was in the National Academy, National Medal of Science winner, Women's Hall of Fame. And according to this guy, Sam Weissman, who I told you a little bit about, the guy with the hair to die for, remember him? So he says, WashU's biggest mistake because WashU wouldn't give her a job. Okay. Nepotism rules. Now it's totally reversed in a certain sense. Now we're looking for power couples almost, okay? But then she couldn't get a job here, so they both left. Not under Compton, post-Compton. You have to have people willing to stand up to tell the other powers that be, no, we have to change the rules, okay? And you have to have someone with that kind of power and or willingness to do so. And at this particular time, we didn't. Okay, so here I'm going to just summarize. This guy hired Eugene Steenberg in physics, just a monster of theoretical many-body quantum mechanics. hired this guy who had more than Here to Die For, let me tell you, but he had that. All these people were in his wake, if you remember that mental image. So I close with a question. What was Arthur Holly Compton's magic sauce? He was personally a star. His students were stars. Remember all those Nobel Prizes, and his hires were off the charts good. Many individual stars do not leave this legacy. What empowered his vision? And that's just the question. I'm done. Thank you. So I'd love to have questions. Yeah.
I was just say, my father was also at Berkeley, friends with Kamen and Lipkin, and working on cyclotron, and he was part of that music group.
Oh, really? What was his instrument?
He was a cellist, and he went to Oak Ridge, now Los Alamos, part of the project, and produced the first carrier-free P-32, and started the whole isotope program at Oak Ridge. He also was a cellist, and he decided to do the symphony. And he founded the Oak Ridge Symphony.
If you just do it, see if he repeats it.
We lost him now. Lee, would you
Yes.
repeat the questions when they ask it? Thank you.
Okay, I will in a minute. I will in a minute.
Kamen and Lipkin remained lifelong friends. Martin Kamen took me to my first baseball game with the Browns versus the Yankees.
What's your name?
Don Cohn, he was
Don.
Waldo Cohn.
Okay, so for the people online, there's a gentleman in the audience whose father was a member of this chamber music group in Berkeley. Presumably your father was extremely good to be in that group. And a scientist, apparently a radiochemist of some sort, and went to Oak Ridge and continued to do science there and have probably immeasurable fun with his cello. So it's a small world. Yes.
This is a question about the chancellorships.
Can you, sorry, can the people online hear the question? Speak up.
Oh,
This is a question about the chancellorships. And when you look at the history, you see scientists as Compton, exclude Shepley, who's attorney. Then along comes Danforth, medicine. Then along comes
Right.
Brighton. And can you explain the tradition during those decades of Washington U having science career people?
So the question was, can I explain why there was a fairly long train of scientists in the chancellorship? And no. Maybe one insight. That's where the money is, or more money there, but you know, in the medicine and science from grants and other activities bring in more money than other sectors of the university community.
Shepley was succeeded by Elliott, who wasn't a scientist either.
Right. So the trend ended, but so I don't have much to say other than that. There is a hand raised. Leon, can you speak up and go ahead?
Yes,
Leon.
I was interested in Weissman's Hair to Die For, and I couldn't help but wonder if Compton had ever considered shaving off his Hitler mustache.
So did people hear that here?
One, yes.
So the question had to do with maybe a contrast between Sam Weissman's rather free coiffure, his hairstyle, and Compton's I don't want a different approach to keeping his hair in order. So it was just a humorous comment, and of course, I have no insight. Everyone has their own trend, and that's only to be appreciated, right? The variety, it should be looked at that way. So another question here, or statement.
From the scientists, Chancellor to Harvard, was the chemist.
Yeah.
And Kamen went on to become the Chancellor of the University of California, Davis, his career.
Or San Diego?
Yeah, it was down in San Diego. Scripps.
Yeah.
Yeah.
Yeah, we didn't hold on to Kamen. He had, as I said, he had a rough period. And well, you know, he was in this book, these accusations drove him close to this being suicidal. And, but he's vindicated in the end. And, but again, Compton had the courage to offer him a position when places that you think of as being liberal bastions like Berkeley wouldn't touch him. And that's a lesson. I mean, it's just got to be known that that's part of our history here. Yeah, there's a question back there.
So what were the salaries of the chancellor and the other assistant at that time? Did they develop rich, or were they scientists who had eager resources financially?
So the question has to do with university remuneration and financial payback or whatever to chancellors and other scientists, and I think it's all individual. There are certain cases where they did become wealthy, and other cases where they didn't. So I have no insight really. I don't think Compton died being extremely rich. Maybe I'm wrong. Al, do you know? Yeah, I really don't know. I think it's highly variable. I mean, Danforth started out that way, so you know, it's
So I have two other alternate comments. The reason I took this breath on the session was the Soviet Union group was his father worked in Los Alamos. Moscow. He got through in 10 or 15 minutes. This man was a junior. His father had worked on it. He was through for about 12 hours. So he still had impressive resources.
absolutely, yeah.
The other comment I have is my roommate.
I'm sorry you can't hear this online. I'll try to repeat some of it.
My roommate in medical school, his dad was a president in the 40s and 50s and taught theology on the same street as I. And so in 1944, he met Bob Oppenheimer on campus after the bomb exploded. And he looked at him, he said, Bob, he said, I know something big went down. Was that you? He said, could be. So the people on the Princeton campus, you know, more than you would think.
Yeah, so the, rather than repeat the question and the comment, I'm gonna build on it and go in a slightly different direction. So I knew some of these principles. There was a movie about the making of the bomb that was shown here in the 1980s. And it was shown here because these people, there were so many people from Los Alamos here. And there's a scene in that movie where Teller is sitting with Oppenheimer and they're discussing, and Teller is saying that he's thinking about signing the Franck-Szilard petition, which was a demonstration, no use on people bomb. It's not to use it on a city, but to rather demonstrate in the ocean. So this petition was going around, but General Groves had locked it up. So people at Los Alamos couldn't sign it. So there was this, in the movie, there was this session between Teller and Oppenheimer, where actually Oppenheimer's trying to convince Teller not to sign this petition. And Teller was alive, Oppenheimer was dead at the making of this movie, so I thought it was kind of revisionist history. Teller would have been interviewed for the movie, maybe wanted to make himself look good. So I went up to these guys who were there and said, could that scene have been true? Because it's not the image you have of these two people, that Teller would be wanting to sign the no use and Oppenheimer would try to prevent people, dissuade people from signing it. And I won't go into all the details that happened after I said this to these guys, but they made me feel like an idiot. And I was. The bottom line was they believed that scene was true, or very likely to have been true, and that the images you have of people are usually shallow, and that the characters are much more involved, with much more depth than you get. And maybe in a slightly different context, I'll tell you a little bit more about what they said. I don't want to go into it right now. But it ended with one of those guys, Sam Weissman, the guy with the great hair, poking me very hard in the sternum. He knew exactly where he hit, and it can hurt, but he wanted to get my attention. And he said, people are complicated, don't ever forget it. And so I only bring this up because people have images of these characters, whether it's Oppenheimer or Teller or other people involved, and they're usually just a veneer of their personality. And that's important to keep in mind.
So you're saying Oppenheimer really did try to convince Teller not to sign this petition, to use it?
Okay, I'm going to go further than I said I would. Yes, that is in the movie. It's between the two.
The opposite of what I would have heard.
Right. Okay, so that's these two people in a room, and Teller's alive to tell the story. So who knows what happened in that room? But I'm going to tell you something that did happen from the principals. Not in the movie, but this was part of this interaction I had afterwards. This group, the piece of this Magnificent Six, were around Los Alamos. We're in Los Alamos, and they knew the petition was there. And they were saying, I wish I could get it so I could sign it. Remember, this is after the surrender of Germany, before the use in Japan. These people, so many of the scientists, okay, we're wondering about what they had created. Okay, so they were talking, and Oppenheimer came up to them. So what are you young guys talking about? They told him. I won't say what he said, but not for polite audiences. But he was very clear he was trying to dissuade them from signing. And that's firsthand. I mean, I'm secondhand, but they told these people, he told those people, don't sign it. And there were many witnesses. He wanted to use the weapon. Oppenheimer.
Yes, because there's a whole story about Oppenheimer after
After.
the war. After we dropped it, he went into Truman's office.
Yes.
And he was all down. It's like, I shouldn't have invented it. I shouldn't have done
Right.
it. And Truman
Threw him out.
Truman threw him out, said, that son of a bitch, I don't want to ruin it.
Exactly right. That story is exactly right. But that was after use.
That was after you. So
And he had a flip. But up before that point, he was hell-bent on using it.
really, okay.
Teller was disengaged. He was working on the super. He wasn't with the main thrust of the theory effort there, and was conflicted.
But well after the war, it was Teller who invented the
But remember,
He was the one-
Russia invaded Hungary in the 50s.
Yeah, oh yeah, okay.
Little story here about
state of psychiatry at this time. I had a cousin, Bernard Radunsky, who worked on the Manhattan Project. He was from St. Louis. After the war, he came back and developed schizophrenia. At that time, there was no drugs for schizophrenia. They did a frontal lobotomy on him. He spent the rest of his life on Arsenal Street, which was a mental institution at that time. And the group that I worked for was covering breathing x-rays at that time. I just remember one time I came in there and I had to read his x-ray. I didn't know much about him. He was more of a distant cousin. This was the state of psychiatry at that
Yeah.
time.
One would like to think that what we do now is less what is it? Less barbaric. Would like to think. Hopefully it's true.
Good morning, Roland.
Okay. Oh,
We're just about at your house and we got the shells square.
if there are any other
Okay, I'll get myself out there.
Yeah,
Maybe, I don't know, 5 minutes at most.
Okay,
We're just coming over on Chester, we're just on, across the bridge at Chesterfield Parkway. Where do we turn? Swingley Ridge here or where?
yeah, Swingley Ridge.
Okay, gonna turn right on Swingley Ridge. And what's our next turn?
Well, I'm not sure which way you were coming, but
We're going in east of the city, east into the city. East.
all right, did you just pass the post office?
No, we're not at the post office. We're in the other, we're coming in from the west side. Are you in Chesterfield Village or what?
Yes.
I'll bring it up.
We're gonna take a left right here at Chesterfield Village.
There's a background conversation going on my
And
computer.
we're looking for
So,
23.
thank you for your
Old
question,
Court.
and I'm gonna end this thing.
George, mute.
All right, I'm guessing you want to take your
There's quite-
second. left.
Wow, huge group. I didn't
Second,
realize how
right,
many.
we're Gold Court. Well, this is it. All
Okay.
right, let's see.
I'll get outside.
Yeah, 823.
Okay, so goodbye.
Yeah, there's his car.
Goodbye, thank you.
No, cars in the
Thank
garage.
you.
I'm sorry you couldn't hear all the questions. That's part of this new world thing.
We could kind of hear. Thank you.
Lee, I think I saw something about the Alsace thing on 60 Minutes years ago, but it wasn't about the German scientists. It was during the